Welcome everyone to the Cloud Native Apps Developer Live event. My name is Rajesh Vishwanathan, and I'm excited to talk about how to bring the value of Cloud Native to building and operating enterprise applications. We've got quite a bit to get through today. We'll start with describing what a typical enterprise application looks like, what distinguishes them, what are their key characteristics. We'll introduce the concepts around Cloud Native and discuss their benefits. Then we'll describe some of the models around transforming your applications to Cloud Native and the decisions and the trade-offs that are involved there. We'll talk about Oracle's portfolio and how that helps you on this journey to the cloud. Then my colleague, Josh Horwitz, will show you a demo of an actual application being transformed to a Cloud Native architecture using the services provided by Oracle's Cloud Native portfolio. Finally, one of our key customers, Peter Mendes from Interac, will describe their journey about building a Cloud Native application. So let's get started. Let's start with an enterprise application. So what are the core capabilities and requirements that make an app enterprise grade? So typically an enterprise application represents a business critical workload, and this demands high performance, and not just high performance, but consistent performance. Another characteristic of these applications is they're able to scale quickly with usage. Traditionally, the scaling has tended to be vertical, so more powerful hardware to run your application. Security has to be very deeply baked into the environment that the enterprise application is running in. Enterprise apps are typically designed with HA, with high availability, because that's the exacting requirements that you have in the enterprise. It's also important to think about governance and audit, because most of these applications are operating in a regime that requires high compliance and governance mechanisms. And finally, most of these applications tend to be backed by a robust support model and detailed documentation about all of the capabilities of the applications. So traditionally, what has this looked like? So most of these applications are designed using application platforms that impose what is effectively a monolithic application architecture. What does that mean? So it really means that all parts of the application tend to be developed, deployed, managed, shipped all together. So you really are kind of waiting on every part of the application in the case of any change to be built up and be ready before you can ship that change to a customer. So the platforms that these applications are built on have a very, very sort of extensive and a comprehensive range of capabilities. So they're enabling all types of applications to be built. And they've stood the test of time. Some of these applications are probably into their second decade or more of serving that mission critical workload. So unsurprisingly, there's a mature ecosystem of partners and tools around this class of application. So a lot of this sounds pretty great, right? But there are some critical challenges. So today, the market expectations are very different from the time when these applications were built, right? All applications today, pretty much, and enterprise apps are really no different, are expected to have updates that are rolled out frequently. So they're continuously delivering value to a customer. Customers are used to now getting continuous improvements as they happen, so they're not waiting for 6 months or a year for changes to trickle through into their systems. For apps that are built using these traditional monolithic architectures, that's actually quite hard to keep up with. Secondly, the capital expenditure is an important consideration here. The CapEx involved for these applications tends to be quite high. You have to pay for the hardware, you're typically paying for software licenses, and you're doing all of this regardless of how many users or what usage the application has. You're effectively sort of paying for peak, as it were. So the model is effectively inelastic, and you can essentially see that your costs are going to be high based on that constraint. Thirdly, most of these applications tend to be built on purpose-built platforms. The platforms are quite extensive in their feature set, but they're still purpose-built. So if you decide that you wanted to use a new capability, or you wanted to leverage some new investment, perhaps in the open source community, where we've seen a lot of innovation over the last few years, you may be out of luck. You're locked into to that particular implementation. You're locked into the vendor of that platform that you chose. And finally, just like we talked about high capital expenditure, your operational costs are going to be significant as well, right? Most of these applications tend to run in environments where you're going to have to kind of manage the maintenance, the patching of the operating systems, the upgrading of the software, et cetera. And more likely than not, you're going to be ending up hiring staff with specialized skill sets, right, that are sort of just for the upkeep of these applications. So that's going to drive up your operational costs in addition to the capital cost challenge we talked about earlier. So let's talk about cloud native. What is cloud native and how is it going to help you in this journey? There's quite a bit of buzz about cloud native. It's hard to not hear from someone these days about how much value cloud native brings to your application model. Whether it be from analysts, whether it be industry experts, general practitioners, everyone's talking about sort of how much the cloud native architecture sort of is the path forward for some of these challenges we've talked about. Before we get to the details, let's actually understand what cloud native really means. So at its core, cloud native is about a change in the culture. It's a change in the culture about how software is developed, deployed, and managed. So the way to think about it is in terms of 4 key aspects. Number 1, it's the concept of changing your development lifecycle to enable frequent releases of your software. And ideally, it's frequent releases of small units of change. So we're moving from the model of infrequent large releases to frequent small releases. How do you make that happen? And that's the key to the second aspect that cloud native encompasses. It's the change culturally and from a technology perspective in the deployment processes. You want to apply the same rigor around your deployment processes and tooling as you do around your development process. If you think about it, when you develop code, we have a fairly significant amount of rigor around QAing it, making sure that there's enough code to be used in the system. The cloud native model says you need to apply that same rigor to your deployment models as well. Make sure that you've got the right gates in place and all of the validation happens automatically. Because remember, we're trying to release change quickly. So number 3 is designing the application to be sort of broken down into sort of loosely coupled what are known as microservices. So the notion of a microservice is that the functionality that a microservices provides is effectively independent and can be run independently from the other parts of the system. So it's still one large application, but you can actually have loosely coupled components of it that can all sort of operate independently, that can scale independently. And they talk to each other via APIs that each of them exposes. So one microservice doesn't go reach around behind to the database configuration of another. Right? You're talking through the front end API of that other microservice. And number 4, it's the use of containers as the packaging mechanism. So containers give you the ability to sort of combine your application with their dependencies and the infrastructure it runs on into one portable format. So this actually makes the entire system nimble because you can now take that and replicate it in many different places, right? And you're becoming more efficient because you're now utilizing infrastructure that you're using to run these things in the cloud much more. Great. So we talked about now how we had challenges with the enterprise model. As you can see, we can now see how cloud native is going to help address some of those challenges. So number 1, you can see that we have an accelerated release velocity where we're actually going to deliver value to the customer quicker because we've set up our processes to do that. Number 2, our pricing model is now elastic. You're really paying for what you use rather than paying for peak. Number 3, in most cloud native architectures, they tend to be built around a kernel of open source. So in the model we have here now addresses the concerns we talked about earlier about vendor lock. And if there's an innovation in the open source community that you want to leverage, more likely than not, the architecture you built that's cloud native will enable you to go do that. Number 4, cloud native architectures tend to encourage designs that are horizontally scalable. So remember how we talked about scalability by sort of finding bigger boxes to run your software on. At some point, you're going to be limited. That's going to be capped. With the model with cloud native is to actually assume that you're running commodity hardware and you're going to run and you're going to deploy those horizontally. So by definition, that actually removes those barriers for you to be able to scale your application. The other thing that cloud native architectures encourage is this notion that failure is not likely. Failure is definite. It's this idea that you want to assume that everything is going to break under you, and therefore you want to design to work even in that situation. So if every component in your software stack assumed that some component below it can fail, by definition, you're going to get a much stronger, resilient system all up, because each system is worried about making sure that it runs when its subsystem fails. Observability is very key to how you kind of operate these applications, right? The cloud native architecture enforces that you're thinking about the logs that are flowing out of the systems, the metrics that are flowing out of the system from the get-go. So once you have that, you can then kind of set up actionable insights based on these logs and metrics. So when your customers have challenges using your application, you're aware of immediately, and ideally you know before they know, because your metrics have started indicating that, and you're already fixing the problem before they even see it. And finally, the deployment and the management of most of these services tends to be fully automated, right? You saw how we have to release software fairly quickly, so it's hard to not be able to do it in an automated way. You have to enforce automation, and once you do that, the benefit you get is you're not now worrying about having to maintain and operate these applications yourself. So you're effectively saving on the operational costs as well. So we saw a whole bunch of benefits around the cloud native model, but we have a lot of applications. We have a lot of traditional enterprise applications. So how do we get there from here? The approach to this is really going to be a function of your business need. So as you can see in this picture, there are going to be some cases where an existing application may just be retired. You may have no use of that application. You think it's better to just not use it anymore. You might also decide that you're just going to go purchase a different version, perhaps, of that application from a different vendor. And finally, you might just decide to leave the application in its current place because that's the business imperative. There are some apps that you decide it's not worth the effort of any sort to sort of modernize it. All of that said, the more likely operations you're going to be taking is really the approaches described in the top right quadrant. So let's consider each one of these. So the first approach is what we call rehosting. In this model, you're lifting and shifting your application pretty much as is into a cloud entity like a virtual machine or a bare metal machine. So you're not really changing the application. You're effectively just changing the operating environment for that application. Right? And in a lot of cases, that suffices, right? That application is now running in the cloud, and you're getting all of the benefits from that. We talked about the elastic pricing model, et cetera. So the next approach is the replatforming approach. So in this model, you're looking to package your application into containers, and then you're deploying that application into a containerized runtime. Kubernetes is perhaps the most common containerized runtime today. So again, you're not really changing the core logic of the application, but now you're actually changing how it's deployed. And in order to be able to do that, you have to think about your deployment systems. Remember, we talked about how you have to change the culture of deployment. So this model is forcing you to sort of apply those notions of continuous delivery and continuous integration and continuous deployment into your engineering development lifecycle. And finally, with the refactoring, you're going even further. You're decomposing your application into smaller microservices. And then some of them, you may decide to move them into a serverless pattern. So in that model, you're basically saying, here's a piece of code, just invoke this code when a certain type of event happens. So as you can see in this picture, these three approaches are not really mutually exclusive, right? Like in some cases, you can start with one, like you might start with replatforming and then move on to the next. So the idea here is that your approach and when you do each of these steps is really a function of what your business needs. So let's talk about how Oracle is going to help you in this journey. So Oracle provides you capabilities across each of these options that we talked about. So there's both bare metal machines and virtual machines that are available if you're choosing the rehosting option, right? And these are built on Oracle's best-in-class OCI infrastructure. And I'll talk a little bit about that in a bit. We also provide software stacks that are available through our marketplace. So you can just bring your application to any one of these and run it on top of that. And finally, as you move further towards the replatforming and the refactoring end of the spectrum, you can leverage our cloud-native portfolio of services. So whether that's going with the containerization option or whether that's going with the serverless option, all of these come with the sort of underpinnings of observability, et cetera, that's kind of implied in any cloud-native architecture. So what is our overall strategy around cloud-native? We really think of our strategy as having 3 pillars. And you can see how these apply to some of the challenges we saw with the traditional applications. Number one, we want to make sure that there is a complete and a comprehensive set of tools and services that you're looking to kind of transform your application into a cloud-native architecture. You want to have all of the underlying building blocks you need to do that. So that's a key strategy for us. We're going to continue to sort of expand the set of capabilities we have to make sure they're filling out that. Number 2 is our open source and our open standards investments. We're very actively participating in our sort of open source communities, whether as participants ourselves, whether as in the form of leveraging some of those, and we're leveraging open source, internally ourselves. And of course, we want to bring the value of that open source to our customers through our services. And number 3, while we deliver all of the value from these open source offerings, we don't want our customers to have to deal with the challenges of that, right? And what that means is having to keep up with the latest versions, for example, or having to do maintenance and upgrades, et cetera. So we want to make these available sort of as fully managed offerings where you get the value. We take care of the operational aspects of this. Not only are we operating it, we're making sure that every service comes with those sort of built-in capabilities around enterprise grade, all of the characteristics that we talked about earlier, high performance, high availability, security built in, meeting the compliance and audit requirements of any enterprise application. So really, that's kind of how we think about our cloud-native applications. It's all of the value of cloud-native, all of the value of open source with the enterprise readiness built in and baked in. So here's a look at our overall portfolio of cloud-native services. As you can see here, it's a pretty comprehensive set of capabilities ranging, across the entire developer lifecycle. So you can, consider scenarios where a customer may be kicking the tires, trying to understand what they can do. And we have an always free tier offering where that gives them a sandbox environment to kind of try things out. And you can then move on to the next stage where they're developing the application or they're integrating it with our building block capabilities like streaming. And then moving on to building and deploying the application into our runtimes, whether it be a traditional runtime like WebLogic, whether it be a containerized runtime like our Kubernetes offering, whether it be a serverless runtime like our functions offering. You may be actually fronting your application with an API and designing and deploying that onto our API gateway offering. And finally, all of this, you want to be able to make sure that you have the ability to observe and manage. And we have a very extensive portfolio for our as part of our observability offerings that provides you all of those capabilities. Throughout the rest of the day today, you're going to be hearing a lot more detail about each of these services. So I'm looking forward to each of those sessions myself. So using this portfolio of our services, you can automate the life cycle of your applications, and that really covers both your existing applications that you're looking to start moving over to the cloud, or net new applications that you're building greenfield into the cloud. We have a number of customers and a number of use cases that are involving transformations like I described. Particularly, we see this happening with high performance applications and data centric applications as well. So all of this said, it's really important to remember that our cloud native services, you have to see them as part of a sort of larger set of, I think of it as the constellation of Oracle cloud services that are provided by the platform. So you can see that this really spans a pretty broad swath of capabilities, ranging from our data processing services to our developer services to our autonomous database capabilities, right? And this also spans multiple developer use cases, whether you're a developer who's using low code or a no code paradigm. You may be an infrastructure developer that's looking to automate your infrastructure deployment. You may be an expert Java developer who's looking to leverage all of the latest in Java, Helidon, GraalVM, etc. So it's really a pretty large set of capabilities. The thing to remember, though, is all of this is built on that very, very strong substrate of OCI core infrastructure. So what that really means is the sort of underlying governance, security, observability, identity, all of those capabilities are just baked in. They're sort of built in from the ground up rather than add-ons that you have to think about later. And with that, I'd like to transition over to my colleague, Josh Horwitz. Josh is going to do a demo that's actually showcasing what I just described to you, taking an existing monolithic style application and showing how you use the cloud native services to transform them into a cloud native architecture. Thank you.
Hello, I'm Josh. I'm a senior software engineer, consulting member of technical staff on the cloud native services. I work on OKE, API gateway, and functions, which are some of the services I'm actually going to talk about. So for today, for our demo, I'm going to kind of walk through, in a very quick timeline, a journey through the cloud native landscape. So for purposes of the demo, we have a bookstore application that is a pretty typical monolithic application. It has it's fronted by a load balancer. We run multiple replicas running on a virtual machine, and it's backed by autonomous database. And so what we're going to do is we're going to make that bookstore a little bit more cloud native by containerizing it, using API gateway, and finally putting some of it on our serverless product or functions. So to start off, like I mentioned, we have our current architecture. Our current architecture is pretty typical for a monolithic application. We have ingress from our customers going through a load balancer, hits our bookstore application, which serves our UI and our API, and it all goes to an autonomous database. So to start our journey, let's look at a book, and that first book is going to be Cloud Native Services. So just to show that everything is working, got to have live working demos. We're going to query our book service, and we see that our book service, we created this book, and we're able to fetch the book. And so now that we're learning about cloud native services, we're going to continue on our journey. And so the next journey is going to be, we're going to extend our bookstore application to actually run partially on Kubernetes. So for purposes of the demo, I've already set up the Kubernetes cluster in the load balancer. And I can show you here that we have our pods running inside of the cluster. So we have 3 pods right now. Those pods are in Kubernetes. We're all sharing the same autonomous database as our current deployed bookstore. And so as we can see, our customers are still looking at our live bookstore application that's deployed on virtual machines. So no traffic is going to our OKE bookstore. But so we want to test it before we start failing traffic over and having customers using our new deployment, our containerized cloud native deployment. So let's first make sure it works. We'll run a similar demo. We're going to create a book called Intro to Kubernetes, since we're playing with Kubernetes. And then instead of querying the OKE store, so if you look up here, we created our book through the OKE bookstore. This is a DNS pointing to this load balancer. So what we're going to do, instead of querying the OKE bookstore, just to prove that we're using the same database, I'm going to query our legacy bookstore. And what we can see is that we have both of our books that we have created so far. We have our cloud native services and we have our introduction to Kubernetes. And so the pods that I showed you earlier in Kubernetes are actually serving the traffic, and they're sharing the autonomous database. And so this is great. We've containerized our application. We basically lift and shifted this into Kubernetes. We didn't have to make really any changes except for how we deploy it. So now the next step of our journey is let's actually get customers to start using this. To start off, what I want to do is I want to put an API gateway in front of our service. An API gateway is an awesome service that not only provides routing capabilities, which is what we'll be doing today, but also provides hooks for authentication, authorization, and eventually serverless, which I'll showcase at the end of the demo. So we're using a very little piece of the functionality, including observability and logging as well, which given time we may be able to see. And so to start off, what I'm going to do, I'm going to make sure that our architecture, by running Terraform, is pointing to the load balancer. Oops. Going to make sure our architecture is pointing to the load balancer. And so we'll let API gateway run. This didn't really have to do anything because it was already pointing there. I just wanted to make sure. So what just happened though, what would have happened is we would have updated the API gateway to ensure it's pointing at the load balancer. This would have been done with zero downtime to our customers. It would have handled connection draining. So now in our cloud native journey, let's make sure our API gateway is actually functioning. So what we're going to do is we're going to, along with our demo, we're going to create a book called Intro to API Gateways. We've created our book. Let's make sure that our book actually works or is inside the bookstore. So we can see that our book is returned. I filtered this on the Intro to API Gateways. And so we've proven that our API gateway is working. This is great. And so if it wasn't a demo, what we would do now is we would take our DNS record that our customers are using to resolve, like bookstore.com, that's pointing to our load balancer, and we move it to point to our API gateway. This would transition our customers to using our API gateway product, which points to the bookstore and will now let us actually move traffic gracefully to our Kubernetes deployment. So moving along, what I'm going to do now is I'm going to run Terraform again. And using Terraform, OCI's Terraform provider, I'm actually updating the endpoint of the API gateway's routes. And so what I'm going to do is this switches the load balancer. So we'll run this, and this is actually live updating our API gateway for our bookstore. And so this takes roughly about 30 seconds or less. And so we'll let this run. If we were sending traffic to our bookstore, the API gateway would gracefully wait for draining before proceeding to the next. And something to call out is, as I mentioned before, the API gateway actually comes built with observability. So all these requests that we're making show up as metrics that you can alarm and graph in Grafana or other tooling, and also access logs. So at this point, we've successfully updated our API gateway. It's now pointing to our Kubernetes deployment. So our architecture now looks like this. Our API gateway line has been severed. So this infrastructure is actually no longer in use. And so what we can do is we can verify that everything is still working by calling our bookstore. And this request, instead of going through our legacy infrastructure, went through the API gateway, went through our Kubernetes load balancer, into our Kubernetes deployment of our bookstore, to our shared autonomous database. And we were able to list all of our books that we've created so far during this demo. And so to recap, so far, we have taken our legacy application, we've containerized it and deployed it to Kubernetes. We've deployed an API gateway that has allowed us to gracefully shift traffic from our legacy application to our Kubernetes and more cloud native application, all while relying on the same database. And so to go one step further in our cloud native journey, let's add a function to the mix. And so what we're going to do is we're actually going to change how our bookstore works a little bit. So today, all of the requests that we've been doing goes through our bookstore. We can get books, we can filter books, and we can add books. And what we're going to do instead is we're going to take adding a book and gracefully move it to a function, because we want to be cloud native, we want to try functions. Maybe this would be new functionality you wanted to try in a function, but for this purpose of the demo, we're going to move an actual endpoint that we have in our current bookstore to a function. So what I'm going to do is I'm going to modify our Terraform. And I already have this pre-populated, so I'll uncomment I'll remove, and as we can see here, currently the routes is pointing to our endpoint that we define, and it's doing get and post. So what we're going to do is we're going to change it from get to only be get, sorry, and we're going to make a post be going to our Oracle function. So I'm going to save that, go back to our demo slide, and now I'm going to rerun Terraform. So now what this is doing is basically what we just saw. We're going to, or what we see on the screen. So what we're doing is we're making API gateways route point to our function instead of pointing to the bookstore for our post. And so as this runs, this should take roughly the same amount of time, which is 20 to 30 seconds. What we'll do then is we'll be able to create a book with our API gateway that actually goes through our function, and then we can query it through our bookstore. So we'll let that execute. Awesome. So the API gateway is successfully updated. So now what we're able to do, let's create a book called Introduction to Serverless, since we're learning about serverless now. So we'll let that get created. Letting the function spin up for the first time. All right, sweet. So the function got spun up for the very first time, and now we're able to successfully query. So now we can see we've gone from introducing cloud native services and moving to Kubernetes. We've introduced an API gateway, and now we've introduced serverless, or our product called OCI functions. And so just to show that this is all the same, we can also query our OKE load balancer directly and skip the API gateway, ensure that it's showing the exact same results. And we have 4 books showing the exact same results. So as we can see, the output of all of our books from this demo, I hope this demo was useful for you to get an overview of our cloud native services. These are just a few services so far that I've discussed with API gateway functions, OKE, that are in OCI's portfolio for cloud native applications. We have more like Oracle's Resource Manager, which could run Terraform for us in a managed way. We have OCI logging and telemetry, which these services support. And actually, I'll briefly show the telemetry aspect of that during this demo. So for this, what I want to show is just, this is going to be our API gateway. And what we will see is, as it refreshes, we'll actually be able to see the requests that we have made during this demo, and some of the requests that I made before the demo to make sure the demo was working. And so API Gateway out of the box provides you with all of these metrics for API requests, responses. We have bytes sent and received, latency. It actually even exposes the internal latency. We can see that the overhead of the API Gateway is roughly around 600 to 400 microseconds, which is very fast. It's not really any overhead. And we're able to see the backend latency from our application and the backend responses. So these are all provided for free out of the box. And we also have the ability to see access logs and more. And similar metrics are provided by our function. I'll refresh to make sure our metrics are up to date. You can see here, we made a single function call, which was the add book that we just made at 23. Yeah. So awesome. And so this precludes the demo. I want to thank you all, and I hope this was useful to get an overview of some of our cloud native services. Thank you, Rajesh, for having me, and back over to you.
Thank you very much, Josh. That was really exciting, and it was great to see all of those capabilities showing up so beautifully. So I'd now like to welcome our close partner and customer, Peter Mendes from Interac Corporation is going to talk about some of their learnings. Peter is Senior Manager and Enterprise Architect at Interac, and will be talking to us about how they build their cloud native applications and how they leverage the Oracle Cloud Infrastructure Cloud Native Services to do that. Peter, over to you.
Great. Thank you, Rajesh. My name is Peter Mendes. Hi, everybody. Just to give a brief background about the Interac. So Interac is a Canadian interbank network that links financial institutions for purpose of exchanging electronic financial transactions. So Interac serves a Canadian debit card system and also email money transfer system, and it's currently designated by Bank of Canada as prominent payment system in Canada. So here in Interac, we drive innovation. So with that being said, Some of our new projects, we have actually leveraged cloud native solutions for accelerating development and also hosting projects in a very, very short span of time. So just to give you, let's take a look at our key design objectives, right? So high availability, that's top number one for us. Okay, so we are talking about higher SLAs, always up and running, 24/7, 365. Rapid innovation, this means no more installing your database on servers, no managing your compute server infrastructure and database servers, repeatable deployment and test instantaneously, and also fail fast. Okay, so that's kind of a repeatable model that we are looking at. Improve observability, that means also telemetry and deep monitoring as well. Automate security standards with the help of infrastructure as code. So that means we are actually looking at tools such as Terraform and Ansible. Deploy small and fast with microservices and containers. Code for resiliency, that means replica sets and scale sets we are going to leverage. Open standards to reduce vendor lock-in, and also scalable architecture. Okay, so these are the design objectives. Next slide, please. Okay, so here we are talking about the logical architecture. So we are talking about one of our new applications, financial services applications that we just building. And be it on the GA. So here, what we are doing is we are talking about the functionality is basically the transfer of money between merchants and financial institutions through user devices. We have been using the following OCA capabilities. If you look, API gateway, Oracle Kubernetes engine, which basically is an uses the upstream Kubernetes. Oracle Autonomous Database dedicated, so that you don't build your own. Oracle Container Registry, which is OCR. So these are the capabilities that we use. So if you look at deep dive into the architecture, we actually, we have the north-south traffics, and all the traffic basically from north-south goes to a third-party DDoS WAF solution. And once it's our ingress through the VCN, it uses the front-facing API gateway, which routes the traffic to the compute layer, which is the AR Kubernetes ingress controller. So we use the cloud-native, ingress controller. We just follow the CNCF. We'll cover it as part of the later on. So basically, what happens is we have this compute layer, which is completely scaled and has multiple replica sets that can scale dynamically based upon the load. So these are the silent features that we use. We are predominantly using all the cloud native functionality in this particular piece. Over to you. Next slide, please. So I want to go some of the best practices we observed at Interac. So as I mentioned earlier, the design for open standards for interoperability and workload portability using CNCF certified tool sets. There are a bunch of CNCF tools, and we ought to be very cautious in taking mature tools, and so that you can actually make the cloud journey as seamless. So especially if you look at the compute layer, there are tons of the tools that you can leverage. And more importantly is the infrastructure as code, right? So Oracle definitely has the Terraform. It supports Terraform, and it's open sourced. You can accelerate your container cluster deployment in a very short span of time. You can build the clusters, build, repeat, and over again. You can destroy, build it at ease. And also secure a cluster. That's very, very important. Bring your own keys, so that you can encrypt your etcd cluster, the Kubernetes cluster, with your own keys, because you're basically using the managed services. We've actually used the CI/CD pipeline to deploy code to OKE, which makes it more repeatable and standard, so that we deploy it in multiple environments with ease. And more importantly, I just wanted to basically highlight is consider using a service mesh for your containers, so that you secure your inter-container communications and also have a very decent service discoverability across the compute. So that's all I have. Over to you, Rajesh.
Peter, thank you very much. I had one follow-up question for you, Peter. I know you have felt quite passionately about, especially the infrastructure as code piece, and I know you provided a lot of feedback on our Terraform providers. Tell us a little bit about how that went.
Yeah, definitely. I just like to highlight, we've been avid user of especially the Oracle Terraform OKE, and the Oracle Terraform team has immensely helped us, to add features, and whatever the features we have asked, they've been very candid and made it available in a very short span of time. So we have, I think, around 5 to 6 new features that we are requested, and everything is being delivered. And hats off, it's been pretty much working with such a wonderful team.
Great, that's great to hear, Peter. Thank you so much. We've really enjoyed working with you and really appreciate your presence here.
Thank you very much, Rajesh.
So before I wrap up, I thought it's important to sort of summarize the key takeaways from our discussions today. And there's a lot more of this that you're going to learn throughout the rest of the day. So your takeaway number one is that cloud native is transforming enterprise applications, how they're built, how they're developed, how they're deployed, etc. Takeaway number two, as we talked about, there are many approaches to how to modernize your application, and there's no one size fits all. This is really going to be a function of what your business needs are. You might choose to re-platform, you might choose to rehost, you might refactor your application. So think about each specific use case individually. And finally, regardless of what your approach is, Oracle's portfolio of cloud native services has a capability or a solution to support that. So take a look at our entire portfolio. Hope you enjoyed the rest of the sessions today, where we'll deep dive into each of these capabilities. And I look forward to hearing more about what you do with all of this. Thank you very much for your time.